Alright, this is Agilent E4407B ESA Sera Spectrum Analyzer, 90 kHz to 26.5 GHz with some options here also. I'll show you. Currently connected with the calibration cable here, and you see that showing 50 MHz at minus 20 dBm. Let's check the attenuator just to show that. As you can see, it's running very nice. Now the unit is fully tested. It'll do preset, but you need a calibration. You need to do a calibration of the signal. It's not a flat frequency, but it's pretty nice, but need to be calibrated to be accurate as it should be. So what I do now, I'll put here a sweeper so you can see yourself the frequency response of the unit. Currently I put this is a 10 GHz signal right now at minus 10 dBm, so here it is here. I'll just put that at the center just to show that span, let's say 10 MHz peak. Now the level is minus 10 dBm. I'm reading here minus 9. That's okay, but it's not always like that. Sometimes it's not minus 8, minus let's say something like that, 8.3 or something like that. So it's a little bit higher. I'll do a preset and I'll do a sweep across the range up to 20 GHz because this unit is 20 GHz unit. So I'll do a stop at the 20 GHz, and I'll do here preset running to 20 GHz at the minus 10 dBm. Minus 10 dBm, okay. No, it doesn't accept that. Minus 10. Okay, now it's okay. And I'll do here a sweep of manual sweep of, let's say, 10 seconds, so we can see the frequency response. And here it is. As you can see, it's pretty nice across the range. It's a little bit higher here and flat here, so it's good up to 20 GHz. When we go in upper above the 20 GHz, get some point that's a little bit higher at 24 GHz. I'll show you. I'll use this this unit here between 18 to 26.5, and I'll show you that. So I'll do frequency start at 18 GHz and stop at 26.5 GHz, and this is the frequency response. Just build up. Just need to ignore this one. Here it is. It's building up, and there's a little bit jump here. Now this line here is the minus 10 dBm, which is this is what I'm providing to it. So it's a minus 10 across almost all the range. It's a little bit hole here and a little bit higher here. So this is the correction you need to do. Take it to a certified laboratory to calibrate the frequency response of this unit. I'll do a preset again, and now we'll see. This is the options here. So you got time gated spectrum, narrow resolution bandwidth, high stability frequency reference, GPIB and parallel. Do the frequency again. So this is the actual unit for sale. It looks very nice cosmetically as well. This is the actual one, and let's see some of the functions. Maybe just put the frequency. This one frequency here. Let's put here, let's say the 10 GHz again. Frequency 10 GHz. Put the span of, let's say, 10 MHz. And here it is. And measure. You can do all this measurement of channel power, occupied bandwidth. Let's try that. And this is occupied bandwidth here. I'll do a preset again. And the resolution bandwidth of this unit is really nice. I'll show you. It's 10 GHz. Let's do a span of 1 MHz and peak. And I'll do here pulses. So just send some pulses. This is the pulses, and see how the unit can discriminate them. So I open the span more and more. If you have a resolution bandwidth of 1 kHz, like without this option, this is what you're going to see. But this unit can show you individual pulses. Now this is resolution bandwidth currently is 300 Hz, and you can see each of the pulses, and even more and even more. That's 300 Hz, and now it's 100 Hz resolution bandwidth, and you can actually measure each pulse and the distance between them. So This is why it's important, this option, to be able to look at the very narrow pulses like a radar or some other. So we'll preset again, and this is the unit, fully tested in good working condition, but need calibration. Calibration of the flatness is not included, so you need to do that. Thank you.